Alrighty guys, so I promised you a video going over page 35, how to do neutralizations. We're going to try this again. I'm going to level with you. This is my third time trying to record this tutorial. The cat is interrupting me, the video cut out, the microphone wasn't working. Let's hope that this is the one that gets us where we need to go. So I am going to be very quickly going through the first example because we already did this one. All right, so we've got water, and I'm going to write it as HOH, and you'll see why in just a second. Here I'm going to have calcium chloride. Now, how do I know I've got calcium chloride? This calcium is going to combine with the chlorine. All right, so that's going to be important for us to know. Now, when we go in, we need to also balance, and we're going to throw a 2 in front of the water because we have 2 hydroxides here, and we're going to put a 2 in front of the hydrochloric acid because we also need 2 hydrogens. We need 2 chlorines so that they're balanced between the reactants and the products. All right, I'm going to try problem number 2 with you now. So this time I'm going to write the water as H2O. I want you to still think of it though as HOH, okay? So here I have my base. My base is a metal and a hydroxide. This metal is going to combine with whatever did not make the water out of the acid. So we have a hydroxide and an H, HOH. That's what went together to make the water. What do we have left? We have a sodium and a nitrate. They are going to combine to form my salt. Now, I don't need any additional subscripts here because the charge on a sodium is +1. The charge on a nitrate is -1. I'm going to get rid of all this extra stuff so we can focus on our balancing. And if we look at it, we don't need to do, we don't need to do anything in our balancing because everything's in a 1-to-1 ratio. All right, coming back to number 3. Here we have our water, and I'm just going to go ahead and I'm going to throw water in all 4 of these because I know one of my products is always water. That never changes. So the first thing I'm going to look at is my base, and I see this magnesium here in my base. That is going to become the metal in my salt. Then I'm going to come over here and look at my acid. I'm going to see that sulfate. That is going to become the anion in my salt. So let's get rid of those. Let's look at our formula. Make sure it's written correctly. So I've got MgSO4. This is perfectly fine because the magnesium has a charge of +2 and the sulfate has a charge of -2. So they cancel each other out, so I do not need them. Let's look at our balancing. In order to balance this correctly, very simple, 2 hydrogens, 2 hydroxides. That means I need 2 waters. All right, let's go to number 4. Number 4 stumped a few of you, and it was in the writing of your salt that you had the issue. So we know we're going to be combining lithium and the phosphate, right? So LiPO4. A bunch of you left it there, and there's a big problem with that. And the problem is that lithium is group 1, and phosphate has a charge of -3. So if you look at this, we've got +1, we've got -3. When we do our crisscross, that means that this formula is correctly written as Li3PO4. And that's where a lot of you got thrown when you did this. So if I told you to look at number 4, that's probably the first thing you needed to look at. Then, because we had this 3 subscript on the lithium, we have to look at the balancing. We're going to need 3 lithiums from our reactants to balance the 3 lithiums in our products. And now we also have 3 hydroxides and 3 hydrogens, and that means that we need 3 waters. Little boy, don't need comments from you. Okay, coming on down to the reverse reactions where we were given our salts and our waters and we have to come up with our acids and our bases. For this, just to keep things consistent, I'm going to put my acid first in every single one of these reactions and my base second in every single one, so you know where I'm putting everything. All right, so when we're looking at these, I want to think about them like this, okay? The metal came from the base. The anion attached to the metal came from the acid. So that means that my magnesium came from my base. My magnesium will always be attached in a base to a hydroxide. All right, now let's check our formula. Magnesium is group 2. Hydroxide has a charge of -1. We reverse crisscross, right? That means that we need parentheses here and a subscript of 2 on that hydroxide group. All right, now let's go to our acid. Our acid is coming from the anion attached to our metal. So here is our anion, it's NO3, and I'm going to attach that to a hydrogen to make our acid. Now, I'm going to look at my charges. This is -1, I know that from table E, and this is +1, they cancel each other out. If I didn't want to go to table E, I could use the formula itself over here as a clue, because here's a trick for you. This is a 2. I know magnesium is +2. That means that if I reverse crisscross my nitrate, it was -1. All right, let's move on to our next equation. And I want to get rid of all this extra stuff. Oh wait, no, I didn't balance. Can't leave you hanging. Okay, so when we balance this one, it's pretty straightforward. I've got 2 nitrates in my products. That means I have to have 2 of them in my reactants. And since I have 2 hydrogens now and 2 hydroxides, I will have 2 waters. All right, let's go to our next one. We have potassium and sulfate. And if I think of my water as HOH, the hydroxide goes with my base, the hydrogen goes with my acid. So here is my base component, potassium hydroxide. Here is my acid component. And now that I have done that, let's check to make sure my formulas are correctly written. Potassium, charge of +1, hydroxide, -1. Good. Over here, I saw this mistake a lot. Pay attention. Our sulfuric acid is, oops, H2, come on, H2SO4, because SO4 has a charge of -2 and the hydrogen has a charge of +1. And that means that we have to have H2SO4. Now, the other way you check that, my friends, is in almost every standard question you're going to have in Regents chemistry, if there's an acid, it's one of our standard acids. It means you can find it on table K. If the acid you wrote isn't on table K, chances are you did something wrong and you need to go back and check it. Now that I have this properly balanced, properly written, I'm going to balance it now. I'm going to look over here. I've got 2 potassiums, 2. And that means I'm going to need 2 waters to balance out the 2 hydroxides and the 2 hydrogens. And now we are good. All right. Let's go to number 7. Number 7 stumped a bunch of you. It was a little more challenging. So here's our calcium. It's going to go with our base. Here's our phosphate that's going to go with our acid. Okay, we're going to think of our water as HOH. We're going to attach that OH to our calcium hydroxide to make our base. But we can't stop because calcium has a charge of +2. It's from group 2. So that means I need 2 hydroxides. All right, this is somewhere a lot of you made a mistake. All right, so now I'm going to write my acid and got phosphoric acid. And if I look up phosphate, it has a charge of -3. Hydrogen is a +1. That means I know I need that 3 subscript on my hydrogen so I have a neutral compound. Remember, that's what this is all about, getting neutral compounds when we are writing formulas. It's all tying together, guys, bringing it all home. So now we're going to balance this one. And out of all the problems, this was probably the most challenging to balance. So the first thing I'm going to do is I'm going to look here and I see I've got 3 calciums. So I'm going to throw a 3 there and then see what effect that has on everything else. So because I have 3 calciums there, that now means I have 6 hydroxides. So I'm going to put a 6 in front of my water because I'm going to need 6 waters to use up those 6 hydroxides. Now if I have 2 phosphates in my products, that means I need 2 phosphates in my reactants. That gives me a 2 here with my hydrogens. That makes 6 hydrogens to match with the 6 hydroxides. So I'm just checking. Am I good? Am I good? Am I good? I'm good. Okay. I'm going to move to our last problem. And so here we've got our barium, that is our metal, and we have our nitrate. I'm just going to do this. I know that's going with my acid. My barium is going to be barium hydroxide. I need to put a 2 here. I know that because the charge on this nitrate is -1, and because there's a 2 out here, I know the charge on the barium was +2. I can also look it up in the periodic table. Hello, it's group 2. All right, our next one, we're doing our acid. This is nitrous acid, and our charge on that is -1, +1. We don't need any additional subscripts. How do we balance this? Pretty easy. I'm going to put a 2 here. I am going to put a 2 in front of my water, and I am finished. Now, before I walk away from this, I'm going to look at what my situation is with the energy, because I asked you to do that as well. Oh, and mark your acids and your bases and your salts. So acid, 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 base, 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 base. These, I put all my salts in the same place. On this side, we already said I filled all those in purpose. And I'm just going to mark my salts here. And in all of these, energy is going to, oh, hello. Going to be in the product side. And that's because every single neutralization reaction is exothermic. That means they all have energy in the product side. Every single one. All right, so that finishes us off. And I just want to say, I'm putting my face out here at the moment because last night I was reading an article that said research shows that if students can see their teacher during remote instruction, that they connect with the material better. And I guess, yeah, that makes sense, right? So if you can stand to see, you know, this, I don't know, 5,000 days in quarantine mug, I'll keep putting it out there if it helps out you. Thanks a lot for tuning in. This has been Periodic Perfection with Ms. Knoll. Have a great day.